Poster Competition 2021, organized by Women in Geospatial Plus, Asia and Oceania regional groups, to mark the World Space Week 2021 and World GIS Day 2021. The aims and objectives were to encourage and award the contributions made by women plus students, enthusiasts, young professionals through the use and development of geospatial technology. The themes for the poster were how to bridge the gender gap in geospatial industry and academia. How does your research address this issue? Changing trajectories of natural resources and landscape. Are they affecting climate change? What solutions can arise from using geospatial technology? Role of women and underrepresented genders in addressing the sustainable development goals. How can geospatial technology solve social issues relating to women and underrepresented genders? The judgment criteria was original research 40%, effective communication 40%, accuracy 10%, design and overall presentation 10%. We are glad to introduce our judge, Ms. Opiemi Kazim Jimo, who is a geospatial analyst and cartographer with interest in disaster risk reduction through geohazard mapping and promoting sustainable futures. She also hosts a podcast to showcase geospatial talent across Africa and beyond. The hosts of this were Regional Ambassador Asia, Dr. Lakshmi N. Goparaju, and Regional Ambassador of Oceania, Ms. Aisha Sheldon. The winners are Ms. Gauri Deshpande, first prize, and Ms. Chansi Shah, second prize. Thank you. You can find us on Twitter and email. Welcome to the poster competition organized by Geosaki, Regional Group of Asia and Oceania. This was an initiative to encourage and award the contributions made by Women Plus, students, enthusiasts, young professionals through the use and development of geospatial technology. We went through a ton of submissions and scrutinized each one. The amount of hard work and determination you all have put into this project is indeed praiseworthy. It was an honor to review your works. With that being said, and it is also one of the hardest decisions our judges had to make. All the works were exemplary and choosing one wasn't easy. We chose two of the best posters which met all of the criteria. So dear Chansi and Gauri, you have an opportunity to present before us and we are glad to invite you to this session. So let me introduce the two contestants here. First is Ms. Gauri Sandeep Deshpande. She has done MSc in Geoinformatics from University of Pune, currently enrolled as a PhD scholar in the Department of Geography, Norosji Wadia College, Pune affiliated to University of Pune. She also worked in an ISRO-sanctioned project related to urban hydrology. We are glad to have you, Gauri, here.
Thank you, ma'am.
Next participant is Ms. Chansi Shah from Kutch, Gujarat, India, who had pursued Masters of Science in Geoinformatics and Bachelor of Technology in Civil Engineering. She has a knowledge and skill in Geographic Information System, remote sensing, geospatial data processing, machine learning, geo-AI, civil engineering, and urban development. She is the global winner of the NASA Space App Challenge 2020 for the best use of data, a global hackathon hosted by the National Aeronautics and Space Administration. She is the winner of 5 national and state level competitions too. She has completed her internship in training and research in Earth Ecosystem program in Space Application Center, ISRO. She has got an opportunity to work in a dynamic environment that has provided a wide spectrum of experience and exposure. So Chansi, there's a lot that we could also learn from you. All the best.
Thank you. Thank you so much.
So I'll call upon Ms. Gauri to start your presentation. I think we'll make you the host, co-host, so that you can share your slides.
Okay. Uh, Everybody is able to see my poster? Hello?
Yes, yes.
Yes, we can see.
Okay. So, hello friends. First, I would like to thanks to Women in Geospatial group as they have given me opportunity to present my research work on this huge platform. So today I'm going to present my research work on impact of impervious surface growth on surface runoff, a case study of urbanizing watershed of Bhima Indrayani Basin, Pune, Maharashtra, along with my PhD guide, Dr. Anargha Dode. So as we all know that urbanization and industrialization have brought dramatic changes on the Earth's surface, which includes removal of natural vegetation, and it is replaced with the non-transpiring, non-evaporating impervious surfaces such as metal, asphalt, concrete, etc. So such altered land use is prone to hydrological problems, and because of that, flash floods are more common in the lower reaches of the basin. So now the question is, are they affecting our climate change? My answer is, or it is a vice versa. Like due to climate change, frequency of extreme events has increased as per various reports. So as per IPCC report 2017, it has been predicted that heavy extreme precipitation events are increased significantly in the monsoon season. So we will get more water in less number of days. So if it is not managed properly, then it will cause the urban flooding. So for that, basically we have chosen the methodology according to the aim that how the impervious surface growth is affecting on surface runoff. So for that, basically we have chosen a Bhima Indrayani Basin, which is a speedily urbanizing watershed, and it is host of many urban centers like Pune, Pimpri Chinchwad, and Chakan, and the various transportation routes are developed like Mumbai Pune Express Highway and all. So with this, the Bhima Indrayani Basin is experiencing a chaotic growth in the recent years. So for that, basically in the methodology, we have acquired the satellite data for considering the 25 years span, that is the 1991 and 2016. Then the pre-processing of the satellite data is done as per the scheduled rules. Then the three approaches are concerned. First is LULC, means land use land cover classification. Then we have performed impervious surface analysis, and the third one is surface runoff estimation. So basically for land use land cover classification, we have done the supervised classification using the maximum likelihood classifier, where we get more than 80% accuracy for both the years. So as we can directly see from here that the land use is increasing, basically the land use built up areas are increasing significantly in the southern part of the image. So these areas are basically Pune and Pimpri Chinchwad and Chakan, and these black lines, these are the transportation routes. So you can see directly that along the transportation routes, the built up areas are tremendously increased. On the other hand, in the 1991, the transportation routes are they are not widened, so they cannot captured in the 30-meter resolution image. So as we see, the built up area is very limited into the pockets. Now, if we concern with the table, we will have the table. So with that also, we can clearly see that the built up area has tremendously increased from 5% to 25% during the 25 years span. And the barren land has decreased because of the reclamation of the land for residential and commercial use. Now, another significant changes occurred in the land use image, that is, in this area, almost the barren and fallow land is dominant, but in 2016, the agricultural activities are also increased in the lower reaches of the basin because of the rising demand of the food, crops, and vegetables for the urban areas, urban centers. So these are the outcomes of the LULC, that is land use land cover image. Further, we have taken the approach that is called impervious surfaces. So basically, for this impervious surfaces, we are used one regression model, population calibrated regression model, which is developed by myself and my guide. So with that model, we have obtained these results. For the model, basically, we have used various parameters like band values, then the normalized difference vegetation index, then the tussle cap index, then population density, slope images, elevation images, because these all are affecting the impervious surfaces. So as we see in the image that in 1991, there is a very less impervious surfaces are present, like the whole watershed is in the 6 to 10% impervious surfaces. But if we see in the 2016, the most of the areas in the lower reaches, lower part of the basin, they are converted into more than 70% of imperviousness. And these changes are more dominant along the transportation routes. This lower part is basically the PCMC, the Pune and Pimpri Chinchwad area. This transportation route, this is the basically the Mumbai-Pune Express Highway. So along that also we are experiencing the high impervious surfaces. This is the Mumbai-Pune-Nashik Highway, NH50. So along that also the Chakan, Rajgurunagar, and all these urban centers are developed. They are having the advantage of Pune, closeness to the Pune and Pimpri Chinchwad, and another advantages of the transportation route. So they are developing in a haphazard manner. And another transportation route is found here in the western part, that is, eastern part, that is the AH Pune Nagar Highway, AH 27. So along that also the impervious surfaces are increased. So if we go on through the imperviousness tables, that one research scholar, that is the Schuller, he has said that if the impervious surface is less than 10%, then the watershed status is protected. If the impervious surface is between 10 to 25, then the watershed status is impacted. And if the IS impervious surface is more than 25%, it is in the degraded state. So basically the imperviousness is considered as an environmental indicator. So as imperviousness increases, the health of the stream deteriorates. So if we consider the 25 years span, then in 1991, almost entire watershed is in the protected zone. But if we see in the 2016, almost like most of the part, almost 90% part of the watershed is in the degraded state. So the care should be taken for the for the watershed, that along these urban centers and all, we have to installations of the penetrating surfaces and all. So the stream health is deteriorating a lot. We have collected various samples also from that site. So it is very much polluted water, and overall, the flash floods, the frequency of the flash floods in the downstream, the urban areas has increased a lot in these 2 years. So as IPCC says that the more water will be received in less number of days. So if there is a high rainfall in one day, then there will be a urban floods because of this altered land use. So the third aspect, that is the as in the methodology table, it is seen that surface runoff estimation. So for that, we have chosen the method that is Soil Conservation Services curve number method. So in the curve number method, we have used the soil data as well as the rainfall data to calculate the curve numbers. Curve numbers are basically, they are based on the land use, land cover, then the antecedent moisture conditions, how much moisture is available in the ground, and also on the soil. So according to that, the soil is classified into hydrological soil groups, and then the Soil Conservation Services curve number method is used to calculate the runoff for the entire area. Now, this is basically the Western Ghat area. The western part of the image is having the Western Ghats where the dams and all are located. There the rainfall is quite higher. So wherever the rainfall is higher, it is generating the higher runoff. So the situation is like like that only, that the western part of the image is generating higher runoff values. And if we see in the graphical presentation that this is on the y-axis, we are having the runoff coefficient, and on the x-axis, this is the watershed impervious area. So as watershed imperviousness areas are increasing, if it is like almost 70%, then the runoff coefficient is also increasing a lot. So this is significantly proof that with the increasing impervious surfaces, we are having the runoff volume more and more. So this is the whatever the three approaches, three designs we have done. So if we talked about the major findings, so during the 25 years of span, the built-up areas had tremendously increased, but this growth is limited to pockets like the southern central part and all. So along the transportation routes, we are having such kind of built-up pockets or impervious pockets. So major variations are found along the major transportation routes. Now, as we have seen in the impervious surfaces, that almost 25, like most of the area is having, in 2016, it is in the degraded zone, which is having more than 25% IS. Then it has also seen that the high level of built-up values always generate high values of runoff. So these regions are mainly associated with the PCMC, that is Pune and Pimpri Chinchwad Municipal Corporation areas. So for that, we have given some of the suggestions to the local government, that for reducing the area of impervious surfaces, we have to construct the permeable surfaces such as interlocking concrete curb pavers or permeable asphalt is also there. Because if previously the soil is covered with the surface, now it is everywhere there will be a cement, which is non-transpiring, non-penetrating. So for that, we can construct the permeable surfaces, the concrete pavers, interlocking pavers, which can percolate the water also, and it will increase the groundwater level, and the other subsurface conditions will be also fine. Then with the use of GIS, we can have the site suitability for green island and rain gardens. So basically green islands are established in the areas of the PCMC, like there are various green parks are there. Then the lakes are there, small lakes are constructed. Then the bioswales is also a vegetated infiltration ditch that allows the runoff to percolate and back into the ground, and it is filtered by the soil. So these are the some suggestions which can be implemented to reduce the surface runoff, and we can reduce the intensity of the surface runoff, the flash floods. So that is the main aim of the study, that what is the like how can we reduce that flash floods, the intensity of the flash floods. So for that, permeable surfaces, green island, rain gardens, and bioswales, these are the suggestions from our side. So thank you, thanks a lot.
Thank you, Gauri. Quite well explained, and the suggestions which you have provided in the last are quite relevant and quite important, because now every metropolitan city, at least in India, urban floods are common.
Yes. Thank you. Thanks a lot.
Thank you. May I call upon Chansey? You will be made the host. Chansey, share your screen and for the presentation.
Yes, ma'am. Yes, ma'am. Can you able to see my screen?
Yes, we have enabled the screen sharing.
Yeah, you can see. I've shared it.
Yes.
Okay. Can I start? Okay. Hello, everyone. Good evening. I'm Chansey Sa. I've completed my master's in geoinformatics and bachelor's in civil engineering. And I would like to thank Women in Geospatial Forum to give me an opportunity to present my research work here. So my topic of research is partial distribution of an electric vehicle charging station, a steps towards a sustainable development. As recently COP26 has came to an end, and every country has tried to suggest and tell that by 2050 or 2030 they are going to be a carbon neutral. But to become a carbon neutral, we have to take a very huge step. And this is a small step which can help an India as well as other countries to be a carbon neutral. The main carbon CO2, carbon dioxide, monoxide came. One of the major sources is our vehicles, transportation systems, which are right now working on petrol, diesels, and fossil fuels. As as these fuels are very limited, as well as the price are also rising, so we have to step towards an alternative. So electric vehicle is one of the very good alternative for the environment as well as for our funding part, for our money, as petrol and diesel prices are rising. Any country's economy depends much on its transportation network. So if we have to convert our electric vehicle from our standard vehicles, then we will need a very solid infrastructure. So my research is work around how we can use our location intelligence to get that most optimum location of the electric vehicle charging station. So people will start adopting it, and we will be more in steps towards reducing the climate change, global warming. So to do this, we have used as Anand is a city, Anand is a district in Gujarat, India. We have taken this as a case study. Our overall perspective is to develop the methodology which can be replicated in all other all other cities and states of the India. So in this thing, we have considered first of all was the land use land cover map, where the people are living. We have to know for planning any particular transportation related project. So the land use land cover map was prepared from the least 3 data. That this is satellite of India having a resolution of 23 meters. Using the time series analysis, we have tried to predict the 2020 location, 2020 prediction of the land use land cover, so that we can know, okay, according to the speed of the city, this much will be the population and this much will be the urban spread of an area. Then the next question come is where we will install the electric charging stations. So petrol pumps are the best location to establish a charging station. And as per the Ministry of Power of India, there is a manual release which says that there should be a 9 kilometer stretch after each electric vehicle charging station. So using the GIS, we have mapped all the petrol pumps of the Iron district. The electric charging needs the continuous power, like 24/7, it needs a power. So along with that, we have also considered the power stations which are nearby, which can give the electricity to the continuous electricity to the charging stations. As well as we have also considered the road networks, so that we can say that people can come and do the charging in a very efficient way. Along with that, we have also considered the various laws which has been given by the power of ministry, that it should be within 9 kilometer by 9 kilometers. It should be nearby built up area. The charging station should be nearby, should be there where there is a 4 corner roads. So all that analysis and whole model was being developed. And finally, we get the locations for the petrol pumps which are most efficient to install a charging stations. Along with that, we have also done a power calculation that if this much is the population and this much population is going to adopt an EV, then how much power will be required. So here we have also suggested few power stations which has to be installed in a near future. In that also we are told to shift towards the solar power or a hydro power, so that electricity is also produced in a renewable manner. Likewise, the whole map and location intelligence is being used to get the most optimal location of the electric vehicle charging station. This will be a small step for the sustainable development, and as we will have a infrastructure for the charging station, people will start adopting the electric vehicle without any hesitations, and will also help us to get a carbon neutral. Thus, I would like to conclude that this solution is mostly for the Iron City, but this was moreover, a plan was to develop a methodology which can be replicated for any congested, suffocated city, which is using a conventional vehicle but needs to be adopted in EV. So people will start adopting it, and we will have a carbon neutral India by 2050. Yeah, thank you.
Thank you, Chansi. A very good vision you have, and a very interesting project and work. And I'm glad that you had enlightened us today on something which is within our reach, and which every city should adopt in near future.
Yes,
So
ma'am. As a not for the presentation, but as a personal, I'm right now working with various organizations and companies so that they can use this project and can have a benefit of it, because now electric vehicles are started, people are started adopting it. That's why. So I'm doing a conversation with all of them and trying to make it as a reality, not only a project.
Yes, very good. All the best. And I think we should all be aware of how geospatial technology can help us in so many ways. So
Yes.
very good presentation. We have Opiami with us today. Opiami, please May we have some 2 words of encouragement from your side?
Okay, thank you so much to the presenters. I really commend the 2 projects that reviewed. For the first one about the flooding in urban centers and impervious surfaces, I would say that it was enlightening. The fact that you used the LULC as well as the other models that you used to detect impervious surfaces. I think that's a very innovative way to do it. I don't think I've really come across a lot of projects that know how to calculate impervious surfaces the way you did. And I really like to encourage you to probably publish this and to do more for us to be, for us in the academia also to be able to use the methods that you use and developed. If you can refine it and publish it, that would be really good. And also for the second presenter, I think that our project was really, is something that is very relevant today in our society. And like you said, electric vehicles are the future. A lot of countries that are going to carbon neutrality and that want to stop burning fossil fuels. In the very recent future, most of us or most countries in the world will have to adopt electric vehicles. And it's also something that I think even other countries in Asia and Africa and other, even developing countries should think about. Although we are not there yet, even for somebody like me from Africa, we're not there yet to the point of saying we'll probably be using electric vehicles very soon, but we'll still have to get there. And it's something that we have to calculate and start planning for it. So I think it's very innovative, the research that you did. And I think that other countries and researchers should also adopt it and start thinking about this. So thank you very much for giving me the opportunity also to review the projects. Thank you so much.
Thank you.
Thank you,
madam.
OPME. And I
Thank
second
you for the
OPME and encourage you to publish these as papers and keep on the good work and keep innovating. So I'm proud of you, 2 young girls. So thank you so much for being here and taking all the effort for presenting as well as preparing for the poster also. Thank you so much.
Thank you, ma'am.
Thank you. Thanks a lot, ma'am.
Thank you, ma'am.